What's up, geeks, and welcome to the channel. If you're a software developer or studying a programming language, you've probably heard of dependency injection. At first, it sounds intimidating. I felt the same way. But it's really just a fancy term used to represent a simple concept. In any object-oriented language, classes and objects are the foundation of everything. Relationships like composition or inheritance let us extend and reuse functionalities, but there's a catch. How we build those relationships, those dependencies, determines how decoupled, reusable, and testable our code is. Say we have a food interface implemented by a burger class and both are used by a chef class with one method: prepare food. Here, the chef is tightly coupled to burger. Without creating a burger in the constructor, it can't prepare anything. Now, imagine our business has grown and we want to prepare pizzas as well. We create a pizza class that also implements food. However, with our current design, to support both types of foods, we either have to replace burger with pizza entirely, as in never make burgers again, or duplicate the prepare method, leading to two identical calls, one for burgers and the other for pizzas. Or some may even suggest creating multiple chef subclasses where each subclass specializes in a particular food type. You get where I'm going. These are all bad solutions. The better approach is to pass a food object to the chef when we create it. So, if we pass a burger to the chef constructor, we get a burger chef, and same applies for pizzas. Doing this exactly, passing a dependency via the constructor, is called dependency injection. We're injecting the dependency instead of creating it inside the class, by the class. This decouples the chef from its dependency, the food. Before, the chef would instantiate food in its constructor, creating a hard dependency using the new keyword. That meant the chef couldn't be reused or tested independently because it was tied to a specific burger object. With dependency injection, the chef no longer needs to know how to create food, it just receives it. If the food implementation changes later, the chef class doesn't care. Okay, there are three types of dependency injection: constructor, setter, and field injection. Constructor injection is what we just saw. Dependencies are passed through the constructor. This is the most recommended approach. With setter injection, the dependency is provided via a setter method instead. So, we create the object with a default constructor, then inject the dependency afterward. This approach hides the dependency. We can't tell if it's required just by looking at the constructor, and that can cause runtime errors like null pointer exceptions. Field injection is the third way. It requires either directly accessing non-private fields or using reflection to modify private ones. This has the same issues as setter injection, plus extra complexity due to field mutation or reflection. Now that we know what dependency injection is and how to use it, let's talk about why we use it. The concept behind it is called inversion of control. It's a principle that shifts control from the program to a container or framework. You see, in contrast with traditional programming, in which our custom code makes calls to a library where reusable code sits, inversion of control enables a framework to take control over the flow of a program and make calls to our custom code. To make this work, frameworks rely on abstractions. We extend their classes or plug in our own. This aligns with the fifth solid principle, which says classes should depend on abstractions, not concretions, and that's exactly what we did. Initially, our chef class depended on burger, which is a concretion or an implementation. With dependency injection, it now depends on the food interface, which is an abstraction. A class should concentrate on fulfilling its responsibilities and not focus on creating objects that are required to fulfill those responsibilities. Dependency injection helps with that. It reduces boilerplate and duplication because the injector handles setup. It also makes it easier to extend functionality and supports the open-closed principle. Open for extension, closed for modification. Testing becomes simpler too because we can easily mock dependencies. But here's the thing, dependency injection is a solution, so don't use it if you don't have a problem. Sometimes injecting dependencies can overcomplicate things. For example, if class A uses class B internally and B is only used by A, meaning B is fully encapsulated and can be considered an implementation detail. Injecting B into A exposes it unnecessarily, creating tighter coupling elsewhere in our system and leading to an overall worse architecture with leaking concerns. Testing can also be misleading. Say we inject and mock B while testing A. Our tests may pass, but we're never 100% sure that the actual production code of A will work with the actual production code of B. All we tested was an injected mock. So, my last word is this: use dependency injection when it makes sense. If not, you could be adding complexity instead of clarity. And that's it for this video. I hope it was helpful. If you learned something new today, hitting the like button and subscribing really helps the channel out. Thanks for watching, take care, and I'll see you in the next one.